Hi dear parents, welcome back to another math hour. Today I'm going to show you how to find the slope of a line using the rise over run principle. This is something fairly new for the students. They've been learning how to use the slope formula. They know how to use the slope formula, m equals y2 minus y1 over x2 minus x1. And rise over run is basically another way of expressing slope, but without doing any math with it. There's no need for formulas for this one. But I will show you basically what this means. Rise over run looks like this. It is a slope. M stands for slope. And basically what you have over here on the numerator, the rise, and down below the denominator, the run. Okay? Now the word rise means you are going to go in two directions. Either you go top or you go to the bottom. Okay? And in the graphing world, when you are moving to the top from one coordinate point to another coordinate point, when you are going up like an elevator, it's always going to be positive numbers. Okay? Likewise, if you are moving from one coordinate point and going down to another coordinate point, that downward movement will be a negative number. All right? And if you look at the run is the other directions. There are two ways to run. Either you can go from left to right, right like this, or you can go from right to left, like that. Okay? And if you're going from left to right, automatically that means that the run or the number is going to be positive. And if you're going from right to left, that means the number, you're going backwards. And if you're going backwards, the number is going to be negative. All right? Let me show you this using some examples. Let's start over here. This is number one right here. We have to calculate the rise and run to find the slope of each line right over here. Okay? And they highlighted some coordinate points for us. In this case, they told us that this coordinate point is 2, comma 1. Okay? And right down over here, we've got, looks like 0, comma, minus 3. Okay? They told us there's two coordinate points, and if I wanted to, I could use my slope formula and just plug it in, the delta y of delta x, and I could find my slope. But I don't need to. Using the rise over run technique, I can find out the slope of this particular line without doing any math. Let me show you how that works. Take a look. And remember, in the graph world, from one coordinate point to the next coordinate point, you always start from the left side. In other words, you start from the left coordinate point, jumping to the right coordinate point, okay? So if this is my starting point, I need to figure out, well, how did I go from this 0 minus 3 to 2 comma 1, all right? It looks like I had to move, obviously, a couple of directions to the right, and then I had to go all the way to the top. Let's find out how many steps to the top. How many steps did I have to climb up in order to go from minus 3 all the way to 1 on the y-axis? Let's count. 1, 2, 3, 4. Aha! I had to climb up 4 steps to go from minus 3 all the way to 1. So that's going to be my numerator, positive 4. You see that? Now I need to jump to this point, and so I'm right over here now, and I need to jump to the right once, twice, and there we go. I reached the coordinate point destination. So I jump twice to the right, which means my denominator will be a positive 2. And there we go. You've got the slope for this particular line. It's 4 over 2, and of course you could simplify it to simply 2. You see that? I jumped up 4 steps and I went to the right twice in order to go from this coordinate point to this coordinate point. And that is how I get my slope using the rise over run technique. Let's go to the next one. I've got over here a linear equation, a graph over here of a linear equation. I got two coordinate points. On this left side, it looks like it is minus 3 comma positive 2. And here on the right side of my graph, looks like it is 1 comma minus 3. And I like to find the slope. I don't need to do any math. I'm just going to use my rise over run technique. Looks like it's going downhill, so I obviously took the elevator down. So let's see how many steps downwards that I have to take. 1, 2, 3, 4, and 5. I took 5 steps downwards. And if I'm going down, then I have to put a negative number in front of the 5. You see that? The negatives indicates that I had to walk downstairs. Alright, now I'm right over here and I need to jump to the right in order to go to this coordinate point. How many jumps to the right? Let's see. 1, 2, 3, 4. 4 jumps to the right. Looks like it's a positive number. And there we go. I keep it a positive number. And so the slope of this particular line is minus 5 over 4. You see? No math needed. Just simple visual clues is all you need in order to figure out the slope. Let's do the last one over here. I've got a linear equation. They gave me 2 coordinate points. Let's see. Let's mark them down. This looks like this is 2, 3 on the right side. I'll put R for right. And on the left side, which is my starting point, looks like it is minus 3, minus 4. Okay? Now, how did I go from this minus 3, minus 4 all the way to 2, 3? Well, it looks like I had to jump up, isn't it? The elevator had to go up. So let's see how many flights of stairs it had to go up. 1, 2, 3, 4, 5, 6, and 7. 7 flights of stairs. Since I'm going up, it's a positive number, so 7 is positive. And then I had to jump to the right in order to reach this coordinate point. Let's see how many jumps. 1, 2, 3, 4, 5. 5 jumps to the right. 5 is a positive number. And there we go. That is the slope of this particular linear equation. Okay? As you can see, no math was needed for this. I did not have to use a slope formula. I can if I wanted to, but I just needed to use the rise over run principle to visually see how to go from one coordinate point to another coordinate point. And just by using those 2 coordinate points, I could figure out the rise and I could figure out the run. Okay? If you can do that, you don't have to worry about using the slope formula. All right? Good. Thank you so much. See you next time.